Now next topic which we will study is halides of boron. So first of all इसमें आएगा preparation of boron trihalides. So first is BF3 boron trifluoride. What is the method of preparation? तो इसमें आएगा B2O3 boron oxide plus calcium fluoride plus sulfuric acid, and if you heat it, we get calcium sulfate, water plus BF3. Then second method is from sodium borate. When it is treated with calcium fluoride and sulfuric acid, we get sodium bisulfate, calcium sulfate, water and BF3. Then another method for preparation is if you treat boron trioxide with HF, तो BF3 और water मिलेगा. Then if you take Na2B4O7 means sodium borate और उसको अगर आप HF से treat करें in the presence of sulfuric acid, then what we get is sodium bisulfate, water, BF3 plus water molecule. So this is another method of preparation of your BF3. Then how it is prepared in laboratory? On laboratory scale, we take disonium tetrafluoroborate, and from disonium tetrafluoroborate we get, this is fluorobenzene, nitrogen plus BF3. This is also a very important method of preparation of fluorobenzene. Then next we have other boron halides. This was BF3. We have other boron halides. Now if you treat B2O3 with carbon and chlorine at 500 degrees Celsius, we get BCl3 plus carbon monoxide. And if you treat it with carbon and bromine, then we will get BBr3. Then another method is if you treat it with PCl5, phosphorus pentachloride, at 150 degrees Celsius, we get PCl3 and POCl3. Then third method, this is formation of boron triiodide. So NaBH4 plus iodine, Bi3, Hi plus Nai. Another method is from BCl3. You treat it with Hi, we will get Bi3 and HCl. Then what are their properties? Now BF3, BCl3 are gases, BBr3 is a volatile liquid and Bi3 is a solid. Now next part is very important. What is the decreasing order of melting point and boiling points of boron halide? So Bi3 has maximum melting point and boiling point, then comes BBr3, then BCl3 and then BF3. Now all boron halides except BF3, leaving BF3, when they are treated with water, they give us boric acid and corresponding acid, halide acid, halo acid, corresponding halo acid. So except your BF3. Then fifth property, very important property, is that boron halides are electron deficient compounds, and boron has before going to that, studying the fifth property, we have the fourth property. Why BF3, that is boron trifluoride, it does not form boric acid? क्यों? बाकी सब तो water पे treat करने पे boric acid बनाते हैं, but BF3 does not form it. So BF bond is very strong bond because of extensive p-pi back. इसमें back bonding है, which I'll explain later on also. As a result, BF bond energy is very large is larger than BOH bond energy, and it cannot be compensated. Therefore, this reaction is not possible. Therefore, this reaction, it is not possible. So, boron halides, then they are covalent and monomeric in vapor phase. They are sp2 hybridized. I think this structure you know. Trigonal planar is the geometry, BF3 120 degrees, and they are sp2 hybridized. Then comes their next property. fifth property, that boron halides are electron deficient compounds. They are electron deficient compounds, and boron has 2 electron less than octet. Why it is? Because you know इसका structure भी आपने पीछे पढ़ा. It is one of the orbital is empty. बोरॉन का एक ऑर्बिटल जो है वो empty होता है. So in boron trifluoride also one of the its octet is not complete. One of the orbit is empty of boron. So BF3, it combines very easily with Lewis space, and Lewis space can donate it electrons. Like you can see BF3, it combines with ammonia. Ammonia is a Lewis space. So ammonia can donate it electrons. It combines with fluoride ion. Fluoride ion can donate it electron like this. Then this is ether, CH3O, CH3. O is having 2 lone pair of electrons, so O can easily combine with, can give electrons to boron. So they can combine in this form. Then next we have relative strength of boron trihalides as Lewis acids. What is the relative strength of boron trihalides as Lewis acids? So this is the order, decreasing order. BBr3 is strong Lewis acid, then BCl3, then BF3. Why? On the basis of इलेक्ट्रोनेगेटिविटी के बेस पे, तो BF3 में जो फ्लोराइड एटम है वो सबसे ज्यादा इलेक्ट्रोनेगेटिव है, तो उस बेस पे सबसे ज्यादा जो लुइस एसिड कैरेक्टर था वो BF3 का होना चाहिए था, फिर CbCl3 का, एंड देन BBr3. बट इट इज नॉट लाइक दिस. This is not like this. BF3 is should have been on the basis of electrovity. BF3 should have been the strongest Lewis acid, but it is not. The order is reversed here. So this anomalous behavior is due to tendency of halogen atom to back donate to fluorine atom. See, this is the, I told you there is one vacant 2p orbital in boron, और फ्लोरीन की जो 2p ऑर्बिटल है दैट इज फुल्ली फिल्ड. तो ये जो 2p ऑर्बिटल है फ्लोरीन का, दैट इफेक्टिवली ओवरलैप्स विद वेकेंट 2p ऑर्बिटल ऑफ बोरॉन. सो इस तरह की बॉन्डिंग को हम क्या बोलते हैं? इट इज कॉल्ड एज बैक बॉन्डिंग. डेटिव बॉन्डिंग भी इसको कहा जाता है. सो जो फ्लोरीन है इट डोनेट्स इट्स इलेक्ट्रॉन टू बोरॉन. So this can be explained like this. In BF3, 2p orbitals of each fluorine atom are fully filled and one of the 2p orbitals of boron is vacant. So since both 2p orbitals are of same energy, दोनों की energy same है, 2p orbital fluorine के, means the energy is comparable, बराबरी की है. So since both 2p orbitals are of same energy, so filled 2p orbital of fluorine transfers its electron to vacant 2p orbital of boron. तो ये जो filled 2p orbital है फ्लोरीन के, ये अपने इलेक्ट्रॉन डोनेट कर देते हैं इस वेकेंट ऑर्बिटल को जो बोरॉन का है. Thus BF bond acquired some double bond p pi bond character. So इस तरह p pi bonding, p is the orbital, that is why, and pi bond is formed. Second bond formed is always the pi bond. और इस तरह BF में one of the BF has this partial double bond character, and this type of bonding it is called as back bonding or dative bonding. As a result of back bonding due to fluorine atom, electron deficiency of in boron, it gets compensated. So Lewis acid character decreases due to this back bonding. But this back bonding is not seen in BCl3 and BR3, क्योंकि यहाँ पे BCl3 के केस में क्लोराइड के पास 3p ऑर्बिटल है और BBr3 के केस में Br के पास है आपका 4p ऑर्बिटल. तो their energy is not comparable with 2p ऑर्बिटल ऑफ बोरॉन. इनकी एनर्जी बराबरी की नहीं है. वन इज, दोनों का प्रिंसिपल क्वांटम नंबर डिफरेंट है. 4p और 2p ऑर्बिटल में बहुत ज्यादा एनर्जी डिफरेंस है, एंड सिमिलरली 3p और एंड 2p ऑर्बिटल में भी काफी एनर्जी डिफरेंस है, तो यहाँ पे इफेक्टिव ओवरलैप नहीं होता है. दैट इज वाई देयर लुईस एसिड कैरेक्टर इट रिमेन्स इंटैक्ट. उनका लुईस वहां पे बैक बॉन्डिंग से कंपनसेट नहीं होता है बिकॉज ऑफ डिफरेंस इन एनर्जीज ऑफ द ऑर्बिटल. So this is the reason behind it. So this is all about halides of boron. Thank you.